All right, so I got the RevC PCB assembled, hand assembled, 710 parts or whatever. Took about 3.5 hours, so not too bad. I think it's probably the fastest I've assembled that many parts before. It's looking pretty good. I've only been doing kind of mechanical stuff so far, and then I'm going to switch into the firmware and make sure that's working. The new switch works well, so basically when you install this cover, it pushes this key switch down. This is just the cherry black that you would find in a keyboard, and it just has a tab here that pushes it down. You've got the Li display connector now. It's a 90-degree locking connector. Same grid charger that we had before. It looks mostly the same. There, of course, were quite a few changes. We now have a beeper. The two holes down here are in different spots. So our beta testers had holes here and there. But, oh, and by the way, this isn't plugged in right now, which is why I'm touching it here. And this would be safe regardless because reasons. But anyway, yeah, it's not plugged in. So these two holes have moved. I needed space for all of this filtering and termination, and same over here. But yeah, no, it's looking pretty good. I've made quite a few test fixtures. I do want to show you the back of this, so I'm going to take this off and show you kind of the new features hiding out behind. So this video is probably going to end up being pretty long because I'm going to kind of walk around this shop now that I've got it all kind of settled in, and kind of show what I've been doing the last few weeks on the hardware realm. Basically building the very small manufacturing line. So under the cover here, you see we have right angle connectors now, and they're latching. These two guys are right angle latching. This one is not. On this one, I put a stud in here that keeps it from unplugging. And the reason I did that is so you can plug this ribbon cable in last, because until you do that, there's no high voltage as long as this switch is off. And when you plug this guy in, anyway, I don't want people touching the PCB down here to latch the ribbon cable. So if we don't like that, I of course can change it. This is in a way where you could put a latching connector there. I just think for safety it probably shouldn't. Next up is the 3 temperature sensors. So the temperature sensors just bolt to the stud. So they're going to tell you basically the case temperature here, or whatever the steel temperature is. These plug in up here. You can see that, well, you probably can't, but this is a surface mount connector. I hate surface mount connectors, but I just could not find the through-hole version of this in stock. So it is surface mount. This one is annoyingly kind of where the latch is. It still works. If I do end up revising this board, or probably before I order it next time, I'll do a little dot rev and move it another 10 millimeters this way, kind of like where this one is, where the latch doesn't hit it. My goal with putting it over this direction was to make the connector easier to plug in the bay, but I think that people are going to probably break this connector off if they unlatch this tab quickly. So that would be annoying. I think in firmware, because I hate these surface mount switches, I'll probably put disables so you can disable any one or more of these if you, for example, break the connector off. This board has 17 temperature sensors on it, so I think if one breaks off, it's probably not going to be the end of the world. Particularly if you're measuring 3 bays or whatever. You might only be measuring 2, for example. Now, as far as keeping the high voltage between these isolated, I bought some clear tubing that I was going to slide over these, but this connector is really difficult to remove. And if I get more rigid tubing, then I'm worried again that it'll break the surface mount connector off. So I think what I'm going to do instead is I'll probably put some kind of insulation around this. The issue is that even though this is technically a double insulation, it doesn't meet the safety high voltage insulation. You need one additional insulation layer, and that way if this, for example, melts down and then melts through that, there's no high voltage touching that. Now, even if that does happen, of course, the MCM can detect the short between the high voltage positive, negative, or any cell in between and the chassis ground. So you would get a check engine light if these were to melt through. But just something that it's still a little washy. I need to kind of figure it out. This is the optimal wiring configuration. This is the 18 plus and 18 minus. So this is the 18 minus and this is the 18 plus, and then that's just a 12 plus there, as they all are. So this is a nice short cable here. This has almost 1.5 foot less cabling in it. Kind of minor details there, but so that's kind of that. This is the first RevC, again hand assembled because the pick and place machine broke. As far as these covers, they are still acrylic right now. So the next round I send my beta testers will be acrylic. I am in the process of getting polycarbonate ones quoted for a reasonable price. My quotes so far have been $96, $65, and I think $28 a piece, not folded. So that would just be flats, and then I have to manually fold them. I think those prices are a bit high, so I've been working with, we have 3 machinists in Austin, and I've had one of them quote it, and he quoted me between $10 and $16 plus materials. I don't think that's actually going to be cheaper, but he's also the only person that can give me these covers within the next 2 to 3 months. Everything, the whole supply chain is messed up right now. So anyway, my guy in Austin, it seems like the cover is going to end up costing $20, $25 just for the flat, and then of course I have to do like 15 minutes of work to fold it. So yeah, the first covers going out will be acrylic. So yeah, let's just kind of walk around the shop a bit, and I'll show you what has and hasn't changed. I've only, I think, put one picture up so far. So this is kind of where I'm doing all the cable and final assembly stuff. I've got my spools of cable. This is a 90-pound spool of 4-gauge wire. It's being held up by an old rifle barrel there, which is nice and stiff. I've got other wire spools underneath here. Let me zoom out a little bit. So I've got other spools underneath here. This can hold up to 4 spools that I use to make all my intermediate cables for example, well, there it is. The 4 wires here, the 2 power cables that come through there. So I'm cutting those all that way. This is my Bms box, which is all my Bms connectors. This shelf is all just kind of tools and such. I do have some conformal coating, so I know we've gotten some feedback from our beta testers to have conformal coating. We've got it. Up top here is the 12 different high current cables, depending on which battery configuration you have. So you can see I have the master for each cable in there right now. The cables do now have Andersons, so that you can make that final high voltage connection after you've hooked up all the battery terminals. So this, for example, is the 18S Plus. The 2 18S Plus actually has 2 Anderson connectors. If possible, you're going to want to not use the dual 18S Plus. It's got the longest routing, it's got 2 Anderson connectors, etc. So here's 2 more cables, and they're all kind of like that right now. I only have the master cables in there. Yeah, got a pile of Arduinos with the new custom bootloader on it. What else? Got our arbor press there. This glass sheet is basically for the pick and place, so I can put that stencil down and not get wood all over my parts. And then this is kind of just layers of chaos. I've got these removable bins kind of for each task. So this is kind of the last thing, which is all the hardware to assemble the fans and whatnot to the cover. Well, I guess to the PCB, and then to install the cover. I've got similar ones for the various kit hardware. So there's 2 kit hard boxes, and then I've got 2 Anderson connector boxes. So this is one of the Anderson connector boxes. And this is the other, both Anderson connector and the battery high current cable ringlets. So that's that. Underneath here is all power supplies. I've got like 120 of them. I've done 25, so I've got 25 that are like ready to ship basically. The aluminum plates, all my SMT stuff. Fun fact, this box right here is about $20,000 worth of LTC 6804s, which is pretty wild. Here's our dead pick and place machine. So I basically hand pick and placed all of these parts today because last night the pick and place machine just wouldn't turn on. The screen stopped working. I've looked at it. I'm not sure what's wrong with it, but the manufacturer came back and said, hey, that's an old machine. We don't build it anymore. Buy a new machine. So what I think I'm going to do instead is I'm going to probably use the Open PNP hardware. I haven't played around with that in a long time, but it seems like it's come really far. They've now got camera vision support. So I'm going to see if I can mount some cameras on here. That is going to take me probably about a week, and I'm not going to build any more boards by hand. It took me 3.5 hours to place all of the parts. Fortunately, I had this nifty tool. It's a little KiCad plugin that will show you where all the various parts are, but this was not a quick process, even with a vacuum pump. So this is a little part picker up, where you can pick the parts up by hand. It basically does what the CNC version of it would do, but just much more slowly. It's kind of back-breaking labor just having to bend over there. Up top is all of our packaging stuff to ship these, foam, boxes, etc. I did look at USPS's Cubic, which is the cheapest shipping they do for people who ship basically the same part again and again and again, which this will be. Unfortunately, the LiBCM packaging, the Cubic requires no dimension to be more than 18 inches, and this width is 17 inches, and it's very difficult to protect. So that's kind of the get up here. Of course, this is all the final assembly labels for all of the connectors, so I've just printed out tons of labels. That's for the high current leads. This is for everything else. So I've probably printed about 20 labels, 20 reels of labels so far, and I've got them up there. I've got the backup in case I need to print more, but that should be enough for the first 100 PCBs. Yeah, that's kind of how this is looking. All of the through-hole stuff I'm doing in the other room, which is where I before was doing everything and just running out of room. So I'm doing all of my final soldering because I have a vent hood in there. And then, of course, I'm also doing my electrical test in there as well. So my final verification tester is in there, or will be in there. Yeah, that's kind of the tour. I'm super bummed again that this machine broke, because it means that our beta testers aren't going to get their RevC hardware for several weeks. It'll probably be the beginning of November. Honestly, it'll probably be the middle of November before they actually get them. So that sucks, but it is what it is. Fortunately, this connector here is all you need to control. It's just a bunch of open drains. And that controls all of the steppers and whatnot. Everything that's not in the actual head, that's the head. And then this other connector is everything in the head, so the vacuum start, stop, the rotation. There's two servos to control the rotation on each head. The vacuum check. So basically, if I can plug this into anything else, then I can use the Open PNP. But I'm just not 100% sure I want to go through all that effort. And so I'm looking at the newer, better version of this machine. This machine has placed millions of parts, and I hate that it broke, and I really hate that the company doesn't support it. I get that it's an old machine, but it is what it is. I think it might just be a sunk cost, where they have a new version of this machine that has camera vision, has much better motion profiles. The feeders are vastly improved that tear the tape off. This thing, that's like the worst part of this machine, is that these reels break. So they've redesigned that, and they're better. It also holds quite a few more reels. So right now I'm placing 95%, more than 95% of the parts with this machine when it works, or with its successor. But I do place all of these parts by hand right now, and a lot of them is because this specific machine has a maximum height of 3 millimeters. It can't place a part that's taller than that. The new version of the machine can place parts up to 5 millimeters, and it can also take, this machine has 27 reels. I'm using 25 of them. I would use all 27 if I had 16 millimeter parts, but I don't. This machine will not place 20 millimeter reels, which means I have to place the 6804s by hand right now. And then also these 4 parts here are too tall. These parts, which is the RS485, they come in tubes, and so the new machine actually has a vibratory feeder, so it can actually take tubes. The Zener diodes, this machine could take them, I just don't have reels for them. I can't place this IGBIT because, again, it's too tall. These caps I still won't be able to place, but I will be able to place this inductor. So at the end of the day, with the new machine, I will still be hand placing these 2 parts, but the new machine can place everything else. Now, of course, I've already taken all of these parts out of the reels, so I will hand place these regardless of which machine I have, because I can't put them back on rails. And also, none of these parts are in stock right now. Like literally, this part is out of stock, out of stock, out of stock. The switch is in stock. The transformer is in stock. These capacitors are out of stock. Inductors out of stock. I mean, like, the supply chain is royally messed up right now. So there's no way I can buy the reels for this. And also, I wouldn't want to not use these parts anyway, because this is several $1,000s worth of parts that I've stripped off reels. Anywho, it is coming along very well, notwithstanding the broken pick and place machine and whatever its successor is. I'll note that we have the new machine at DD. We use it for one of our simpler PCBs, the one I just mentioned, the new machine that I just mentioned, and it places parts much better. So at the end of the day, an $8,000 machine, over 100 boards, going to add about $80 to the cost, assuming you sell 100 boards or whatever. So it does mean LiBCM will get more expensive if I buy that machine. Is what it is. Not going to lose money making this product. Or maybe I will, but I'm going to try not to lose money making this product. So anyway, thanks for watching. That's kind of the state of it at the present. I'm going to go and test all the firmware out now and see how well all the fixes are, if any. Thanks for watching, as always.